Hey everyone, welcome back to the lecture series of MCQs of CBSE 10th Chemistry. Previously we completed two chapters MCQs, that is chapter number 1 and 2. Today we are going to start with chapter number 3, that is metals and non-metals. My name is 𝗞𝗃𝗠𝐰 and you are watching 𝗞𝗃 classes. Let's get started. The first question is, which of the following statements is correct about metals? First one is, metals form positive ions by losing electrons. Metals form negative ions by losing electrons. Metals form positive ions by gaining electrons. Metals form negative ions by gaining electrons. First of all, metals form positive ions by losing electron is the right option. Let us take one example of sodium. We know that sodium is a metal whose electronic configuration is 281. So to get its octet complete, sodium will be losing one electron and will convert into Na+, whose electronic configuration will be 28. So what did we see here? We saw that sodium lost one electron to convert into positively charged ions. So here sodium metals form positive ions by losing electrons is the correct option. Next question is, which of the following is the characteristics of metals? Metals have got many characteristics we know. They are hard solids, they are sonorous, they are lustrous, they are malleable, they are ductile, they are good conductors of heat and electricity. So let us see what they are saying here. They have 1 to 3 valence electrons. This is absolutely correct for metals. Metals have 1 to 3 valence electrons and that's the reason they lose electrons and convert into positively charged ions. Let us take example. Sodium we just saw. Let us take example of magnesium. The configuration is 282 and that's why magnesium also loses 2 electron to convert into Mg2+, that is 28. Let us take another example, aluminium, whose configuration is 283 and aluminium also loses 3 electrons to convert into Al3+. So metals have 1, 2, 3 electrons in their valence shell. 1 electron for sodium we have seen, 2 electrons for magnesium and 3 valence electrons for aluminium. So metals will have 1 to 3 electrons in their valence shell. Next question is, gold is used for making jewelry. What are the properties of gold make it a suitable metal for making jewelry? First is ductility. Absolutely correct, because in jewelry we have to make them thin wire. We have to convert the metals into thin wire, and ductility is that property where we can draw the metals into thin wire so that is it. So ductility is important for making jewelry. Malleability is also required because malleability is a property where we can beat the metals into thin sheets. So malleability is also important. Lustrous, yes, obviously the jewelry should be shiny, that is lustrous, so that is also required. So all of this is the correct option. The next question is, aluminium is used for making cooking utensils. Which of the following properties of aluminium are responsible for the same? Good thermal conductivity. Definitely we need good thermal conductivity for making food. Good electrical conductivity is not required. Ductility is not required. High melting point also is required, because if the aluminium has low melting point, then it might melt at high temperature. So good thermal conductivity and high melting point. 1 and 4. 1 and 4 is option D. Next question is, which of the following metal has highest melting point? Options are copper, silver, sodium and tungsten. We know that tungsten has highest melting point and that is the reason it is used in the filament of bulb. Okay. Next is, the only metal which is liquid at room temperature is mercury is the metal which is liquid at room temperature. Which of the following oxides of iron would be obtained on prolonged reaction of iron with steam? The answer is Fe3O4. We know the reaction where iron reacts with steam reversibly to give you Fe3O4 plus H2. This reaction we have done in chapter number 1 also, where we are asked to balance this chemical equation. Okay, so this is the reaction where iron reacts with steam and forms Fe3O4. The oxide is ferroso-ferric oxide or tri-iron tetroxide. This is also called as tri-iron tetroxide, so or ferroso-ferric oxide. So the next question is, which of the following reactions show that a given oxide is amphoteric in nature? Amphoteric, the meaning of amphoteric is both acidic and basic in nature. So ZnO, Zn plus O2 ZnO, ZnO plus H2SO4, ZnSO4 plus H2O. This reaction shows that ZnO is basic in nature, because this base reacts with acid. H2SO4 is an acid, we know. So base reacts with acid, we get salt and water. So in this case, ZnO is reacting as a base. Next reaction is ZnO plus NaOH, Na2ZnO2 plus H2O. In this reaction, we know NaOH is a base, ZnO reacts as an acid, and that is why they are giving salt and water again. So these two reactions where here ZnO acts as a base and here ZnO acts as an acid, these two reactions togetherly shows that ZnO is an amphoteric oxide. So D option, B and C together will be the right option. Next question is, what happens when calcium is treated with water? When calcium is treated with water, calcium plus water will give you calcium hydroxide, right? Now in this reaction, what happens, let's see, it does not react with water. No, this is not the right option. It reacts violently with water. It reacts less violently with water is the right answer, because potassium and sodium reacts violently with water, calcium reacts less violently with water. Bubbles of hydrogen gas formed which sticks to the surface of calcium. Bubbles of hydrogen gas formed. So here it will be basically hydrogen also. So this will be 2H2O. Ca plus 2H2O will give you CaOH whole twice plus H2. So bubbles of hydrogen gas form which stick to the surface of calcium. Even this is correct. 3 and 4. 3 and 4 is the right option. Next question is, which of the following acids does not give hydrogen gas on reacting with metals except magnesium and manganese? Here the answer will be HNO3, because we know that HCl and H2SO4, when they react with metal, they release hydrogen gas, but HNO3 does not do that except Mg and Mn. So Mg plus HNO3 if we react this, and that is also very dilute condition, we get magnesium nitrate plus hydrogen. So in this case we get hydrogen, and even with magnesium the same reaction happen. That is dilute HNO3, very dilute HNO3 gives you manganese nitrate plus hydrogen. Only these two metals react with very dilute HNO3 to liberate hydrogen gas. Otherwise, if you react sodium plus HNO3, there will be no reaction. Any other metal will not react with HNO3 to liberate hydrogen gas. They will react, metals will react with HNO3, but they will not liberate hydrogen. Now the reason behind it is, HNO3 is a very strong oxidizing agent, and that is why even if the hydrogen is formed, it is converted into water, or hydrogen is oxidized to water. So that is the reason HNO3 cannot liberate hydrogen with metals, reacting with metals only except magnesium and manganese. The next question is, complete the following reaction. Al2O3 plus HCl gives you dash and dash. So HCl here is an acid, and aluminium oxide, we know that it is an amphoteric oxide. So when this is an acid, aluminium chloride oxide will react as a base and will form salt and water. So which salt will be formed here? AlCl3 and water. So the options are AlCl3 and water. C option is the correct option. The correct order of increasing chemical reactivity is, for this we need to know the metal activity series. And what is the metal activity series? The metal activity series is, to remember this, you can remember like this: केदार नाथ का माली आलू जरा फीका पकाता है. And then you can also remember high coat है a So this is Ag, this is Au, and this is Pt. So Kedar for potassium, Nath for sodium, Ka for calcium, Mali magnesium, Alu aluminium, Zara zinc, Fika iron, Pakata lead, that is plumbum, Hai hydrogen, and then again we can remember high hydrogen, coat copper, Hai mercury, that is hydrogen, Ka. A is Ag, Au and Pt. So this way we can remember the metal activity series. So here we can see Fe is less reactive than Zn. Yes, Fe is below Zn, so Fe is less reactive than Zn. Zn is less reactive than magnesium and magnesium is less reactive than potassium. So this is the right option. Next is, which of the following reacts with concentrated sulfuric acid but does not react with FeSO4? Zinc reacts with concentrated sulfuric acid, and zinc also reacts with FeSO4 because zinc is above iron, so zinc will replace iron. Mg can react with FeSO4 because Mg is again above iron, so Mg also will react with FeSO4. Potassium also will react with FeSO4 because potassium is above iron, but Pb cannot because Pb is below iron, so Pb cannot react with FeSO4. So this is the right option. Next is, which of the following pairs will give displacement reaction? Again we have to see which is a stronger metal. Or if it is stronger metal, then only it can replace or displacement reaction can take place. ZnSO4 solution and aluminium. Aluminium is stronger than Zn, so aluminium cannot replace Zn from ZnSO4, so this will not happen. FeSO4 solution and Ag. Ag is much below than Fe, so Ag is less stronger, so it cannot replace Fe from FeSO4. MgCl2 solution and aluminium metal. Again Mg is more reactive than aluminium, so aluminium cannot replace Mg from MgCl2. AgNO3 solution and copper metal. Copper can replace Ag because copper is more reactive than Ag, so copper can replace Ag from here, so this is the right option. Next is, which of the following metal will not give hydrogen with water? Sodium plus water will give you NaOH plus hydrogen. I am not balancing the reaction, I am just writing the products over here. You can balance it like this, you can balance it. Magnesium plus water will give you MgO plus hydrogen. Zinc plus water will give you ZnO plus hydrogen. But here copper plus hydrogen, water will not react because if you see here, copper is below hydrogen, so copper cannot replace hydrogen from water. So this reaction will not happen. So copper cannot give hydrogen with water. Let us come to question number 16. Few particles of zinc are dropped in copper sulfur solution. The correct observation is, zinc is dropped in copper sulfur solution. If I see the reaction, zinc plus copper sulfate, since zinc is more reactive than copper, it will replace copper and it will give you zinc sulfate plus copper. So basically copper sulfate is a blue color solution. So the blue color of copper sulfate will fade away, and also we might see a reddish brown deposit of copper. Now let us see what are the options. Blue color of copper sulfate solution fades, this is right. Solution becomes black, no. Solution changes to red color, no. Solution becomes silvery white. So blue color of copper sulfate solution fades. Solution changes to red color is not the right option. If they give red precipitate is obtained because copper will be precipitated down as a reddish color. So that is why they might say, if in the option it is given that reddish brown precipitate is obtained, then it is the right answer. Otherwise solution changes to red color is not the right answer. Okay, so here blue color of copper sulfate solution fades away. Next is, copper sulfate solution can be safely kept in a container made of silver and lead. This is partially true and false because copper sulfate solution can be kept in silver, because silver being less reactive than copper, there will be no reaction. But if copper sulfate is kept in lead container, then lead is more reactive than copper and there will be a reaction. So this statement is partially true and false. Next is, non-metals are electropositive in nature. Absolutely not. Non-metals are electronegative in nature, so it is false statement. Which of the following is not a property of non-metals? They are neither malleable nor ductile. This is a property of non-metal. They are brittle. This is also a property of non-metal. They are sonorous. Not, absolutely not. They are not sonorous at all. They are poor conductor of heat and electricity, except graphite is a property of non-metal. Generally, non-metals are not conductors of electricity. Which of the following is good conductor of electricity? It is graphite. Graphite is the exception where it conducts electricity. So today we have covered 20 MCQs from acid, base and salts. In our next video, we are going to cover more MCQs from the same chapter. So stay tuned and thank you so much.